Hi, I'm Paul Rigge. My SURE research project is in the field of digital communications and information theory. Wireless communication systems have to work in the presence of noise. Satellite messages need to be heard over the background noise of the rest of the universe, and we expect our cell phones and Wi-Fi to work even if someone turns on a microwave. How can we build systems that communicate reliably through an unreliable channel? One simple way is to repeat the message several times. Even if there is a mistake, we can use the multiple copies to figure out what happened. Unfortunately, this has the side effect of being inefficient. It takes much longer to send data. But it does expose an important idea, that we can trade off reliability for speed. Claude Shannon, a 1936 University of Michigan graduate, computed the maximum rate we can reliably send information in his landmark paper, A Mathematical Theory of Communication. However, he did not describe how to actually achieve this rate. Jump forward to 2009, and Erdal Arikin discovers a code that can achieve this capacity, called polar codes. This is not the first code with this property, but it is the first with a mathematical proof that a practical decoder will work reliably. Although polar codes have many theoretical advantages, researchers have yet to make them better in practice than existing codes, such as turbo or LDPC codes. My research for this summer consists of three main goals: developing software that aids in analyzing and constructing polar codes, understanding why polar codes are not performing very well in practice, and finding practical ways to improve performance of polar codes. These tasks involve a lot of thinking, programming, and discussion. I'm fortunate to be working with three fantastic professors: Zhengya Zhang, Achilles Anastasopoulos, and Sandeep Pradhan. It is very rewarding to work in uncharted territory on a problem of both theoretical and practical interest. I've made significant progress on all of my goals. Instead of trying to come up with an analytical formula to build better codes, I've developed software that will simulate thousands of experiments to find a good code. This simulation-based approach also eliminates some shortcomings in previous analytical methods for constructing polar codes. I hope to continue my research and help make polar codes viable alternatives to turbo and LDPC codes. These improvements can one day help make cell phones and Wi-Fi faster and more power efficient, leading to a new generation of wireless technologies.